hydrogen fuel cells have been identified as a promising technology to provide sustainable energy in both the transportation and energy sectors. These electrochemical devices produce electricity by combining hydrogen and oxygen in a chemical reaction, with the byproducts being only water and heat. This makes it a clean and efficient source of energy with the potential to revolutionize the way we generate, store, and distribute energy. However, the widespread use of hydrogen fuel cells is hindered by the challenges associated with their production. The production process of hydrogen fuel cells is complex and involves several steps that require significant investment in research and development to make the process more efficient and cost-effective. The first step in the production process is the extraction of hydrogen gas, which can be obtained from various sources, including natural gas, coal, biomass, and water. Electrolysis is the most common method of extracting hydrogen from water, but it requires a significant amount of electricity, making it expensive. After extracting hydrogen gas, it must be purified and compressed for use in fuel cells. This step is critical as hydrogen gas is highly flammable and must be purified to remove any impurities that could cause a fire or damage the fuel cell stack. Additionally, hydrogen gas is typically stored at high pressure to maximize its energy density, requiring specialized equipment and facilities for safe storage. The manufacturing of the fuel cell stack is another crucial step in the production process. The fuel cell stack is the heart of the fuel cell system, consisting of multiple individual fuel cells stacked together. Each fuel cell consists of an anode, a cathode, and an electrolyte where hydrogen gas is introduced to the anode and oxygen is introduced to the cathode, with the two gases reacting with the electrolyte to produce electricity, water, and heat. The fuel cell stack must be manufactured to precise specifications, requiring advanced materials and manufacturing techniques. Finally, the fuel cell system must be integrated into a vehicle or other energy application, requiring specialized engineering to ensure safe and efficient operation. The infrastructure for storing and distributing hydrogen fuel must also be developed, including the construction of refueling stations and modification of existing infrastructure. Despite the complexity and challenges associated with hydrogen fuel cell production, the potential benefits are significant. Hydrogen fuel cells offer a clean and efficient source of energy that can reduce greenhouse gas emissions and dependence on fossil fuels, while also potentially reducing energy costs and increasing energy security by diversifying our energy sources. Recent years have seen significant progress in the development of hydrogen fuel cell technology, with advances in materials science, manufacturing techniques, and engineering making fuel cells more efficient and cost-effective. Additionally, the development of hydrogen refueling infrastructure has made hydrogen fuel cell vehicles more practical and accessible. In conclusion, the production of hydrogen fuel cells is a complex and challenging process that requires significant investment in research and development. However, the potential benefits of hydrogen fuel cells are significant, offering a clean and efficient source of energy that has the potential to revolutionize the way we generate, store, and distribute energy. With continued investment and research, hydrogen fuel cells have the potential to become a major contributor to a sustainable and secure energy future. Toyota is one of the leading automakers when it comes to developing and implementing hydrogen fuel cell technology. They have been at the forefront of this technology, with their innovative Toyota Mirai being the first mass-produced hydrogen fuel cell vehicle. In addition to the Mirai, Toyota is also exploring the use of fuel cell technology in buses. In 2018, Toyota introduced its second-generation fuel cell bus, the Sora, which uses the same fuel cell stack as the Mirai. The Sora has been designed to provide a more comfortable ride for passengers, with a low-floor design and wider doors for easier boarding and disembarking. However, the production of hydrogen fuel cell buses requires a complex and highly specialized production line. Toyota has invested heavily in the development of a production line specifically designed for the production of fuel cell buses. The production line is located at the Motomachi Plant in Toyota City, Japan, and is capable of producing up to 24 fuel cell buses per month. The production line for Toyota's fuel cell buses involves a number of complex and specialized processes. The first step in the production line is the production of the fuel cell stack. The fuel cell stack is the heart of the fuel cell bus and is responsible for generating electricity from the hydrogen fuel. Toyota uses a proprietary process to manufacture the fuel cell stack, which involves the use of advanced materials and precision manufacturing techniques. Once the fuel cell stack has been manufactured, it is integrated into the fuel cell module. The fuel cell module is then installed into the chassis of the bus. The chassis has been specially designed to accommodate the fuel cell module, with additional space reserved for the hydrogen tanks, electric motors, and other components. The production line for Toyota's fuel cell buses also includes a number of quality control processes. Each component of the fuel cell bus is carefully inspected to ensure that it meets Toyota's high standards for quality and reliability. This includes rigorous testing of the fuel cell stack, as well as testing of the various systems and components that make up the fuel cell bus. One of the key challenges in the production of fuel cell buses is the need to ensure a reliable and efficient supply of hydrogen fuel. Toyota has addressed this challenge by developing its own hydrogen production facility located next to the Motomachi Plant. The facility uses a variety of sources to produce hydrogen fuel, including solar power and waste heat from the production process. Toyota's investment in the development of a specialized production line for fuel cell buses is a testament to their commitment to advancing hydrogen fuel cell technology. The production line represents a major step forward in the development and production of fuel cell buses and is helping to make this technology more accessible to consumers. In conclusion, Toyota's production line for fuel cell buses represents a significant investment in the future of sustainable transportation. The line has been designed to accommodate the unique needs of fuel cell technology and is helping to make fuel cell buses a more practical and accessible option for consumers. As Toyota continues to invest in this technology, it is likely that we will see more fuel cell buses on the road in the coming years, helping to reduce emissions and improve air quality in cities around the world.
You can immediately see for yourself the main difference between the production of cars in the USA and European countries. This is what the assembly of the AMG engine looks like at the Mercedes factory in Germany. And this is what it looks like inside the Ford factory in the US state of Kentucky. Let's start with the car factories in the United States of America. They often prioritize mass production and economies of scale. They tend to be larger in size and are geared towards producing a high volume of vehicles efficiently. Traditionally, US car factories have had a more adversarial relationship between management and labor, with strong unions often influencing labor practices, wages, and benefits. These strong unions are the reason why workers at American car manufacturers are usually dressed in normal clothes, caps, t-shirts, or even shorts. European car factories tend to have a more collaborative approach between labor unions and management, which can result in more flexible work arrangements and a greater focus on employee well-being. Therefore, they have a mandatory dress code and usually wear overalls with the car company's logo at work. American car factories have been at the forefront of automation and robotics in manufacturing, aiming to increase efficiency and reduce labor costs. The US regulatory environment tends to be more lenient in certain areas, which can impact the design and production processes. Another difference is that American car manufacturers often have more geographically dispersed supply chains, with parts and components sourced from various locations, both domestically and internationally. American car culture has historically been focused on larger vehicles, such as trucks and SUVs. This can influence the types of vehicles produced and the manufacturing processes employed. The US government may provide incentives or subsidies to the automotive industry, which can impact the location and operation of car factories. Now we can compare these facts with car factories in Europe. Specifically, we will look at the Porsche, Mercedes-Benz, and BMW factories in Germany. European car factories often emphasize a more diversified approach. They may produce a wider range of models with a focus on customization and attention to detail. These car manufacturers have also embraced automation, but may balance it with a higher degree of craftsmanship, particularly in luxury car production, where manual work and attention to detail are highly valued. European car factories operate under stricter environmental and safety regulations, which can lead to different engineering and manufacturing practices to meet these standards. European car factories benefit from a more centralized supply chain, with a dense network of suppliers, often in close proximity, contributing to tighter integration and potentially quicker response times. European car culture tends to prioritize smaller, more fuel-efficient vehicles, and there's a stronger emphasis on design and performance, particularly in countries like Germany and Italy. European car factories have their own strengths in innovation, particularly in areas like advanced materials, safety technology, and efficient drivetrains. European governments also offer incentives and subsidies, but the regulatory landscape and focus areas may differ. It's important to note that there can be exceptions and variations within both the US and European car manufacturing landscape, and trends may evolve over time due to global economic and technological shifts. Additionally, factors like mergers, acquisitions, and collaborations between American and European car manufacturers can also influence the characteristics of their respective factories. According to the US Bureau of Labor Statistics, an average auto worker makes about $28 per hour. This wage increased about $1 from the year before. In states where the Detroit 3 automakers have factories, workers are striking for better pay. The hourly wage in the German automobile industry was $32 per hour. Of course, this will vary depending on the specific car manufacturer. Car factory workers typically wear a range of protective equipment to ensure their safety and well-being while working in the manufacturing environment. The specific equipment can vary depending on the job role and the tasks being performed. Here are some common types of protective equipment worn by car factory workers. Safety helmets are worn to protect the head from falling objects, impacts, and other potential hazards. Safety glasses or goggles. Eye protection is crucial to shield against flying debris, chemicals, and other potential eye hazards. Workers in areas with high noise levels, such as around heavy machinery, may wear earplugs or earmuffs to protect against hearing damage. In environments where dust, fumes, or harmful particles are present, respiratory protection may be necessary to ensure workers breathe clean air. Depending on the tasks involved, workers may wear gloves to protect their hands from cuts, abrasions, chemicals, or extreme temperatures. Safety boots or steel-toed shoes. These provide protection for the feet from heavy objects, sharp materials, and potential crushing hazards. Workers in areas with moving vehicles or machinery may wear high-visibility vests or clothing to ensure they are easily seen and identified. In areas where workers may come into contact with hazardous chemicals, specialized clothing may be worn to protect against chemical exposure. In areas where there is a risk of fire or exposure to high temperatures, flame-resistant clothing may be required. For tasks performed at heights, workers may wear harnesses, lanyards, and other fall protection gear to prevent falls. In situations where there is a risk of chemical splashes or flying debris, face protection may be worn in addition to safety glasses or goggles. These may be worn to protect clothing from dirt, grease, chemicals, or other substances. In confined spaces, workers may wear safety harnesses or belts to prevent falls and ensure they can be rescued if needed. It's important to note that the specific protective equipment required can vary depending on the tasks and hazards present in a particular area of the factory. Employers are responsible for providing and maintaining appropriate protective equipment, as well as ensuring that workers are trained on how to use it effectively. Additionally, workers should always follow safety protocols and wear the required protective equipment to mitigate potential risks in the workplace.